The name of the topic is Data Encryption Standard, which is also known as a DES. It is a symmetric key block cipher, which means that we use the same key for the data encryption and decryption. It is published by NIST, which is known as National Institute of Standard and Technology. It is a block cipher. So let's talk about the general structure of DES, which is we send the data in 64-bit plain text, and when it goes through DES cipher, the output becomes 64-bit cipher text, which means that we send the plain text to a DES cipher, and it gives the output in a cipher text. And 56-bit key is used in this. In the same scenario, if we want to convert the cipher text into the plain text, let us we call it DES reverse cipher. We send the 64-bit cipher text which came from the DES cipher in the previous block and then send to a reverse cipher. It will give us a plain text. Now, how it do this? So, to make it more clear, here is a second diagram. When we send the 64-bit plain text, the data is go through an initial permutation. Now in the DES system, there are 16 rounds from where the data follows that 16 rounds, and then at the end it gives the ciphertext to S. Now, when the 64-bit cipher plain text is go through an initial permutation, there are various rounds. Round 1, round 2 and so on up to round 16. Each round has its own key which is of 64-bit, but in the above we talk about that we use the 56-bit key for the ciphertext. So it is a generator. It is a round key generator which is of a 56-bit cipher key, and from where we use a 48-bit key for each round. When the data is go through the final passes from the 16 rounds, then there is a final permutation and it will give us the output of 64-bit ciphertext. Now, we mentioned there that there are 16 rounds, but what is happening inside these 16 rounds? So let's talk about it. As I mentioned above that there are 16 rounds and each round is known as Fistel cipher and it has its own key. So now to make it more clear, we have a 64-bit data and let us convert it into a half, we take 32-bit data in the left side and 32-bit data in the right side. We divide the data in two halves. So what's this in? From this diagram, we send the 64-bit plain data to a initial permutation and then it passes through our 16 rounds and then a final permutation. But what happens after the 16th round? The data came from the 16-bit round is swapped with each other. For example, that when we divide the data in two halves, the data came from this will swap with the right and the data from right side swap with the left side. This is the main point. Now each round is a Fistel cipher. Here we divide the data. So let us while swapping the left and right both, the left L1 will go to the right of R2 and the data came from R1 will go to the L2. But it's not a right way to do this. We use a key in each round and this is the key which we used. There is a 32-bit R1. The data is applied to the key and then we we take a XOR of L1 and the output comes from the R1, then it will go to the R2. Now the question is that here we are just applied the key in the one side, why not in L1 to L2 side? This is the all scenario of round 1. So when we go in round 2, again the data swaps. Now the R2 goes to a L3. It means that we applied the key in the above and that data goes to in L3, and there the data came from R1 to L2 will go to the, again we take the XOR with the key FR2K and then send it to R3. So this way we use a 16 keys for 16 rounds and the data swaps again and again. The main thing in this is the main equations that we followed, and very important thing is Li. So what is Li? Li is the leftmost side is equal to Ri minus 1, and Ri is equals to Li minus 1 XOR of Fri minus 1 and the key. So these two equations are made from this diagram as I all explained in it above. So yeah, this is all about the DES system. Thank you.